Good day, viewers. You are welcome to today's math class. So many people used to complain about the W Lambert function, but today we'll be using Newton-Raphson method to solve this nice question. Now, I want you to know that the graph of this function goes like this. So, and we know that it intersects in this side because 36 is in between 30 and 44. So, this implies that there's only one real solution for x, right? So since we know that, firstly, let's take the log of both sides. Therefore, we're going to have log x raised to the power of x is equals to log 36. Now, using the law of logarithm, when you have log a raised to the power of b, this is equals to b log a, right? So here we have x log x is equals to log 36. Now, we have x log x is equals to minus log 36 is equals to 0. Now, f of x to be equals to 0, therefore we are going to have fx x log x minus log 36. So now, we know that when we make a guess by saying 3 raised to the power of 3, we have 36. We have 27, which is not up to 36, right? So 3 cannot be the answer. So let's make another guess again. Look at 4 now. 4 raised to the power of 4 is equal to 256, which means 4 also cannot be the answer, right? But what do you think now? You notice that this 4 raised to the power of 4 is more than 36. So this implies that s is in between 3 and 4. So we can just write it like this. But s is less than 3 is less than x, while x is less than 4, right? Therefore, the value of s is in between the two. So let's make an initial guess of x0 to be equal to 3.5. So, but in order to look for the next approximate, we are going to be using the formula which says x is the next one that we are going to be. Let's say the next one is x1. Is going to be x0 minus the fx divided by the derivative of fx, right? So now, we have gotten our fx to be this. So let's look for the derivative. Now, if you look at this very well, we are going to be using product rule. This yield is 0, right? So we'll focus on this, and here we'll be using product rule, whereby x here stands for u and the log x here stands for v. So to use product rule, it will be u multiplied by the derivative of b plus v multiplied by the derivative of u. So that's what we're going to do. So we have u, which is s, multiplied by the derivative of v, which is log s. The derivative of log x is 1 over x. So at the other side, we are going to have log s, the derivative of u, which is x, and the derivative of x is 1, right? So we have the derivative of fx to be equals to, this cancel out this 1 plus log x. Now, we can now rewrite this as, to look for our next approximation, it will be x0 minus the fx. Don't forget, fx is equal to x log x. So this x will be x0, right? So it will be x0 log x0 minus log 36 divided by the derivative, which is 1 plus log x, which is x0. Now, if you substitute the value of x0, which is 3.5, our first guess, we are going to get the approximate value of 3.144369 because of time. So if you substitute the value of x0 into this, you are going to get an approximate value of 3 point, which is x1. So in order to get x2, it will be x1 minus x1 log x1 minus log 36 divided by 1 plus log x1. So the value of x1, you are going to substitute it here in order to get the next approximation, which is x2, right? So when you do so, you are going to get 3.135648. to get the next approximation. So you continue doing this to get the next. So the next one will be S3. When you do it the same way we did on this, you substitute S2. So you are going to get the approximation of 3.135642. So do it the same way to get S4. But do you know what? Are we still going to continue doing it like this to infinity, or are we going to stop? Yes, we are going to stop. So if you want to stop, you stop when the difference between the previous approximation and the next one is very slim, or there's no difference at all. If you take a careful look at S3 and S2, you can see that there's no difference at all. So this shows that this is the closest approximation to the value of x. Therefore, our value of x is 3.135642. So guys, this is our final answer, or this is our value. Please don't forget to like, share and subscribe to my channel. Thank you. This is Newton Raphson method.